after we found the exponential form of this number, cosine theta plus I sine theta, now let's find the exponential form of cosine theta minus I sine theta. As we know, this is the conjugate of this number. Okay? Again, using the definition of the cosine, e to I theta plus e to minus I theta over 2, and the sine of theta as e to I theta minus e to minus I theta over 2i. We plug them here. But before that, we need to compute the norm. So the norm of z is just the square root of the real part square plus the imaginary part square. Okay, but using our definition, our properties, so this is cosine theta squared plus sine theta squared. Okay, so but we know this is 1, so the square root of 1 is just 1. Okay, now let's go back and change the cosine for this by this expression and the sine by this expression. So we have z as cosine theta minus I sine theta equals e to I theta plus e to minus I theta over 2 minus I, we don't forget this I, e I theta minus e to minus I theta over 2i. Okay, so we can cancel by this I here, and we get, we factor by 1/2, we get e I theta plus e to minus I theta minus e I theta plus e to minus I theta. Okay, and we cancel by this one here, so we get 2e to minus I theta over 2, which is 2e to minus I theta. So that means our z here. Okay, we'll go back and get a geometric explanation for all these results. But remember that we have found that z is 1. The norm of z is 1. So we don't need to write the norm of z here because it's already z is 1. Okay? Because we know the the exponential form is always written this way. Z is the norm of z e to some angle. For our case, for this z in particular, okay, so the norm is 1 and the angle is minus theta. So this is the argument of this complex number is minus theta. Okay, so we will use this one later when we need it. It's very important to know this one. Okay, so like when you have, if you have theta is, let's say if you have theta is pi over 2, what's this case? You have z is equal to in this case e to minus I pi over 2. Okay, and according to our definition, what's this one? So it's cosine pi minus pi over 2, which is pi over 2, plus I sine minus pi over 2, which is okay. So the sine of minus, let's do this one, 0 minus I sine of pi over 2, which is 1, so it's minus I. Okay, so e to minus I pi over 2 is minus I. Okay, so this is very useful. Sometimes we need it to do some computation or to do some changes in some formula, especially when dealing with computation of integrals or doing residues. Okay, so here we need to pay attention. So this is useful sometimes, and we're going to use it later, definitely.